All right, back from holiday and back in the pan. I've been itching to get back on this project as there's a couple of niggling things that have been bothering me about the way I've been architecting the execution of my workloads. And I've drawn some diagrams to illustrate why it's a problem. You'll see in a moment here. So imagine you have a list of Cloud Scheduler jobs. They're all independent from each other. You'll have a job for ingestion, transformation, loading, and each of those jobs has an individual HTTP post trigger into individual Cloud Run jobs. So for example, an ingestion scheduler job will go to the ingestion Cloud Run job, and it will execute a VM in that fashion. However, the problem starts coming when you start scaling up the number of jobs you want to run. Once you start scaling up into hundreds of jobs, you'll need to start spinning up hundreds of Cloud Run instances in order to serve all of those pipelines, which is a bit annoying because it creates a very high maintenance overhead when you're trying to manage this pipeline. And I think there's a much more simpler way we can manage that through the usage of PubSub. And I will show you a new diagram with my proposed design, and it will illustrate the improvements in a moment. So you can see it's a very similar image. It's not very clear how it's been improved, but just follow along with me. So you have the same list of Cloud Scheduler jobs, and instead of having HTTP post triggers embedded inside of them, instead we are going to be triggering a PubSub message to land in a topic of our choosing. Inside that Cloud Scheduler job, we're going to be sending the name of the job within the message body. So it's going to land inside that topic. The PubSub topic is going to push that into a singular Cloud Run service. And based on the job name that you're sending it, it's going to know which workload you want to initiate. So if you send it the ingestion job, it's going to load up the virtual machine with the ingestion job Docker image. The same goes for any transformation jobs. If the job name contains the word transformation, it's going to pull the Docker image with the transformation name, and it's going to do a separate work stream. And these can all run independently at the same time. And the tail end of the process hasn't changed. So they will automatically terminate the virtual machine after the workload has finished executing. So hopefully you can see why this is much better. You don't need to configure 100 different Cloud Run jobs. Instead, we have a singular Cloud Run service that can initialize any different job that you are feeding it via the Cloud Scheduler interface. So I think the best way to illustrate how this looks like is just to jump into GCP and show you what's been changed. Currently you can see that the VM instances are not executing, so just keep a note of that in this video. We go into the Cloud Scheduler. And you can see we currently have two different jobs. We've got an ingestion job for loading in raw data from the API, and we got a loading job which loads that data into BigQuery. And we can go into one of them and we can see the configuration. And we've made a change here. So instead of using the HTTP target type, we're going to be using PubSub. And we've already made a PubSub topic ahead of time for this specific purpose. We've labeled it start VM topic. It's going to receive messages from the Cloud Scheduler with the following message body. So it's a very simple message. We're feeding a job name and the name of the Docker image that we want to execute. So we've created a bit of continuity here between the cloud scheduler name, the name of the Docker image, which makes it very easy to connect the dots between what you're executing in the scheduler and what you're pulling from Docker. It's a very natural progression in terms of knowing what you're executing. And yeah, that's pretty much it. I will go into Artifact Registry. I will go into Artifact Registry to validate that these things are in alignment. So if you go to Artifact Registry, and where we're saving all of our Docker images is inside this Docker chess repo. If we dive into that, we can see this VM initializer Docker image. This is what's running our Cloud Run service for pulling up the different workloads. And this chess GCS ingestion Docker image is what's running the ingestion portion of our pipeline. You can see here that the chess ingestion name is in alignment with the name of our cloud scheduler job. So it's very easy for us to connect the dots between what we're executing and what we're pulling from. So it's worth keeping that in mind. So there you have it. We've got a cloud scheduler, we got our images inside the Artifact Registry, and the naming conventions are in alignment. I think what we can illustrate now is how are we initializing the virtual machines with the correct image names. So for that, I think we'll need to go inside our project and find the script. And we made a few changes here, but we'll go into the main.py file. And since we're transitioning away from Cloud Run jobs do not allow you to use event-driven behavior. Therefore, we have to transfer this into a Cloud Run service style application, which means we need to have Flask as a dependency. And we need to have this Flask set up at the top of the script, and also for the main function that's going to be handling our logic, we need to have this app route decorator when we're executing this VM initialization script. So I'll just quickly run down the different things that are occurring. We have a function that initializes a logger, so we can do some monitoring when things are executing. And we also have a create instance with container function, which simply runs a gcloud command for running our virtual machine. So essentially we just feed it an instance name, which is going to be in alignment with what our cloud scheduler name is, and the container image, which again is in alignment with the naming convention that we've proposed inside the cloud scheduler. So all of those things are connected. It makes it very easy to trigger the correct thing. And yeah, you just run that as a sub-process inside the cloud service. Inside this Docker image, it's using some kind of Google SDK base image, which allows you to run gcloud commands. So it makes it very easy to pull virtual machines up in this manner. If we go into the pub/sub handler, which is kind of the meat of the process, we've got the initialization variables for configuring our virtual machine. You can tweak it if you want, but these are going to be like the default values. And it's going to be receiving messages from the pub/sub topic. So we have this envelope variable, which makes a request to get the JSON from that pub/sub message, and we're simply just parsing it out, decoding the base 64 within that message data, and we need to parse out the job name, since that's going to be critical for us in terms of targeting the correct Docker image to run the correct workload. So for the job name, we just insert it at the end of this artifact registry path to pick up the correct Docker image. And we're also switching our tagging system. We're just going to be using the latest tag at the end of all of our images. It just makes it easier for us to deploy things to production, and it minimizes how many changes we need to make when we're pushing things into prod. Anyway, so once you have all the job names from your pub/sub behavior, we simply just run our VM creator, initialize the virtual machine, and you're going to have your workload running. So again, if you trigger an ingestion job from the Cloud Scheduler, it's going to send an ingestion job name to your pub/sub topic, which goes to your Cloud Run service. The Cloud Run service decodes that pub/sub message, and it's going to feed it into the script, and it's going to tell it, I want to run the ingestion image. And that's pretty much it. That is pretty much it. So yeah, that's it. What we can do is I can illustrate for you how this works in practice. We can do a little test run where we manually trigger our Cloud Run scheduler, and we'll monitor all the things that we're interested in terms of validating that our system is working correctly. So we need to go back into the Cloud Console. Let's go into the Cloud Scheduler. Okay, so we got our two workloads here. I think I'm going to go with executing the ingestion job. So we can do it by simply hitting that check mark and hitting force run. And this is now going to send a message into our pub/sub topic. We could go to our Cloud Run service and do some monitoring from there to validate that the virtual machine has been created. So we got our virtual machine initializer here. And we can go into the logs and see what's occurring. So we can see, okay, 29th of June. And this was just like a few seconds ago. We've got like a decoded pub/sub message here. So this is the exact payload that we're sending within the Cloud Messenger, where we've got the job name key and the name of the job that we want to run, chess GCS ingestion, which is coincidentally the same name that we have in Artifact Registry for our Docker image. So we know that our virtual machine is up and running. We can actually validate it by going into the VM instances. So the VM instances indicate that we've created the new virtual machine. We can go into the log explorer now and validate that it's pulling down that image and actually executing the contents of that script. So let's go into that now. Let's have a look. So it might take a few minutes here for us to actually pull down that image and run the workload. So we're just going to sit here and monitor and wait for that to happen. And that will be our validation in terms of confirming that our VM initialization is working correctly. We can see that we're successfully pulling player data from the chess API, and that's all working as intended. So I'm not going to run that fully. I'm actually going to prematurely delete this virtual machine since I don't want to run the entire workload. But yeah, that just gives you an idea of how it works in practice. The pub/sub method is much more scalable for running hundreds of independent workloads. You have your singular service, and you can spin off hundreds, even thousands of workloads independently, which is very convenient, and it's more easily maintainable than what I had previously, which is nice. And yeah, that's pretty much what I have for you, and I'll see you guys in the next one.